right, today we're going to be taking a look at solving systems of equations with substitution. So we've solved systems of equations before, but we used the graphing method. And now we're going to be using a different method that relies more heavily on algebra to solve these systems. So the same ideas apply here. A system of equations is just when we have two or more systems working together. And so in this case, we're going to be looking at linear equations. And so if we have two lines, the same idea applies where those two lines could intersect and have a single answer, which is the point of intersection. The lines could be parallel to each other, in which case there's going to be no solution because the lines are never going to touch. And we could also have a line that actually ends up being the same line, and in that case, it's infinitely many solutions because any point on that line is a solution. So substitution, if we're looking at this definition here, it says it's a method of solving systems of equations by substituting equations within one another. So the steps are pretty straightforward. Step one is we're going to solve one equation for x or y. When I say we're going to solve it for x or y, it just means we're either going to get the x by itself or the y by itself. And the way we'll decide which one we're going to solve for is just whichever one is easiest to get by itself. So it's going to take some practice to identify that, but we're essentially just going to get one of the variables by itself. Once we have that variable by itself, and we have an x equals or a y equals expression, we're going to substitute that expression into the other equation so that there is only one variable, x or y, and we're going to solve for the variable. Okay, so the idea here is we're going to be substituting one expression into another equation in order to solve for a single variable, and then we will use that solution in step 3 to substitute this solution into the equation from step 1 to solve for the other variable. So this will make a lot more sense as we work through some examples. So let's take a look at the first one. In these examples, we're going to use substitution to solve the system of equations, and then we're going to check by graphing since that's a strategy we're familiar with. So this first one is y equals 2x, and then 4x minus y equals negative 4. So the idea here, if we look back at step 1, is that we want to solve one equation for x or y. So we want to get one of the variables by itself. Well, in this one, the y is already by itself. I have y equals 2x. Y equals 2x. So the work of step 1 is already done for me because I already have y is equal to something. So if y equals 2x, that means in the second equation, anytime I see y, I can actually plug in 2x instead, which will give me a single variable, and it'll allow me to solve for x. So I'll walk that through just so you can see what I'm talking about. So I'm going to rewrite the second one. I have 4x minus, now instead of writing y, because y is equal to 2x, I'm just going to plug in 2x for y, and everything else stays the same. So all I did here was wherever it said y, I plugged in a 2x. Now you can see this is like step number 2. We want there to only be one variable, and there sure is. I have 4x and 2x. There are no y's. The y disappeared because I substituted in the expression 2x. So now that I only have x's, I can solve for x. So 4x minus 2x, those are like terms. If I have 4 x's and I take away 2, I'm left with 2 equals negative 4. To get x by itself, I'm just going to divide both sides by 2, and I'm left with x equals negative 2. So I was able to solve for x. Now I'm not finished now because this is a system of equations. I have an x and a y. But now that I know what x equals, I can now plug this in to my original equation up here, and I can solve now for y. So now I have y equals 2. Instead of writing x, I'm going to plug in what x equals, which is negative 2, and that's being multiplied. So y equals 2 times negative 2, which is negative 4. So I was able to solve for x and y. And get the answer here. So if we go back to a method that we're more familiar with, we can go ahead and graph these and verify that I have a point of intersection at -2, -4. So this first equation, y equals 2x, it's already in the form y equals mx plus b. I'm going to change to green here. Y equals mx plus b, where, b in this case is 0. So that's my starting point. M equals 2, b equals 0. I'm going to start on 0. A slope of 2 means I'm going to go up 2 over 1. So I'm going to be following this pattern here. Down 2 over 1, down 2 over 1, down and over, like this. So this is that line. Okay. Now to graph my second equation, I need to get y by itself. I need to do a little bit of work here. Change colors. Okay, so I'm just gonna kind of move this over so I can have some space to work. I'm gonna do 4x minus y equals -4. I'm gonna subtract the 4x. So I get -y equals -4x minus 4. I'm gonna get rid of this -1. I'm gonna divide everything. So I get y equals 4x plus 4, where m equals 4 and b also equals 4. So to graph this, I'm going to start up on 4, and a slope of 4 means I'm going to go up 2, 3, 4, and over 1, and down and over 1, down 2, 3, 4, over 1, and there I have my point of intersection on the graph. So if I substitute it correctly, this point should be the point, x is -2, so the point -2, -4. So let's check it. I go over 1, 2, and down 1, 2, 3, 4. Sure enough, that is correct. So that is definitely my solution. My solution is -2, -4. So in the future, you will use either graphing or substitution to solve. I just wanted to show you both ways, first as a review, and second just to verify that our answer was correct. So we're going to move on to the second one here. This one, I have to do a little bit more work because going back to step 1, I need one of the equations, I need a variable by itself, and neither of these equations have a variable by itself. So what I want to do is get a variable by itself in the easiest way possible. So this y has a 3 attached to the front, so does this 2 and this y, but this x is almost all by itself. The only thing in the way is this 3y, which just needs to move. So I'm going to go ahead and move this 3y to the other side, and that will get this x by itself. X equals -3y plus 7. Now I'm going to take this expression, -3y plus 7, and I'm going to use that, I'm going to substitute it into this second equation here. Anytime I see x, I'm going to plug in -3y plus 7. So here we go. I have 2 times, instead of writing x, I'm plugging in -3y plus 7. And then I continue with everything else. Minus 4y equals -6. Now, this one's a little bit more challenging than the last one because I need to distribute here so that I can simplify. So I'm going to distribute 2 times -3 and then 2 times 7. So 2 times -3 gives me -6y. 2 times 7 is plus 14. This -4y just drops down, equals -6. Now I can combine like terms. I have a -6y and a -4y, so I'm going to put those together. They're on the same side, so I don't need to move it. So -6 minus 4 is -10y. This 14 drops down. Now I want to start getting the y by itself, so I'm going to subtract 14 from both sides. I'm left with -10y equals -14 minus 6 is -20. Divide both sides by -10, and I get y equals 2. So that was quite a bit of algebra there, but I finally got it by itself, y equals 2. Now before I move on, I need to also find what x equals. If I go back up here, I see that x equals negative 3y plus 7. Now that I know that y is 2, I can easily solve for x. So x equals negative 3. Instead of y, I'm going to put 2. So times 2 plus 7. So x equals negative 3 times 2 is negative 6 plus 7. So x equals 1. So my solution here should be the point, if x is 1 and y is 2, my solution should be the point 1, comma 2. So we could verify that by graphing each of these, which is also going to take a little bit of legwork. So I'm just going to let you go ahead and do that, but we should end up with a solution of 1, comma 2. I'm going to go ahead and move on to the word problem. Okay, so moving on, this problem says, oops, move this out of the way. Come on. Okay. Tickets to a movie cost $7.25 for adults and $5.50 for students. A group of friends purchased 8 tickets for $52.75. So they want us to write a system of equations to represent the situation and then solve how many adult tickets and student tickets were purchased. So I want to break down the information that was given to me. Tickets cost $7.25 for adults and $5.50 for students. So a group of friends purchased 8 tickets for $52.75. So if I'm writing a system of equations, that means I want to come up with more than one equation because I'm solving for 2 things, adult tickets and student tickets. They're not telling me, oh, 5 adult tickets were purchased. I have to actually figure that out and how many student tickets. So to solve for 2 things, you need to use 2 equations. So looking here, I want to try and pick apart 2 different things, and I can find that. I have money, so $7.25, $5.50, and $52, and I also know the total number of tickets purchased. So I'm going to use all of this information to write my equations. So starting with just the number of people who went, I know that 8 tickets were purchased. So if we let A stand for adults and S stand for students, what we have here is the number of adults plus the number of students who went is equal to 8 because 8 tickets were purchased. So however many adults went plus however many students, that should equal 8. So that's my first equation, and it's just talking about the number of people who went. Next, I'm going to factor in how much each ticket cost. So I know that it costs $7.25 for each adult. So that's where I'm going to write 7.25. That was the cost per, so times each adult. Plus, students were only $5.50, so $5.50 times however many students. And if we find the total amount of money spent on adults plus the total amount of money spent on students, that is going to be equal to $52.75, which was the total amount of money spent. So this is my system of equations here. My first one is A plus S equals 8, and my second is 725A plus 550S equals 52.75. So using the substitution method, because graphing can be pretty tedious, the first thing I want to do is get one of the variables, either A or S, by itself. So the easiest one to work with is obviously going to be this first one, A plus S equals 8. So I'm just going to try and get one of these by itself, and it actually doesn't matter, so I'm just going to go ahead and move the S by subtracting it. So when I subtract S, I'm left with A equals 8 minus S. So now I'm going to use this expression, and anytime whenever I see the A here, I'm going to actually plug in 8 minus S. So I'm going to work that out. So I have 725 times, instead of writing A, I'm going to write 8 minus S plus 550S equals 52.75. Now I only have, the only variable I'm working with now is S, which is what I wanted to happen. So now I do need to distribute over on this side, and that means I need to multiply 725 times 8. So I'm going to grab a calculator here. I don't have one handy. Okay, here we go. So I have 725 times 8, which is 58, minus 725 times S, because I'm distributing, plus 550S equals 5275. Now I'm going to combine like terms here because I have negative 725S plus 550S. So if I add those together, I'll end up with, I have 725, negative 725 plus 550. That's going to give me a negative 1.75. So I have, whoops. Uh, 58 minus 1.75 S equals 5275. I can subtract the 58 from both sides. I'm going to move this over here. So I have negative 1.75 S equals 5275 minus 58 is negative 525. If I divide both sides by 175, negative 175, sorry, I will finally get this S by itself. So negative 525 divided by negative 1.75 gives me 3. So S is equal to 3. All right, now that I have S, I'm going to go back up here and I'm going to plug in that value to solve for A. So S, remember, is the number of student tickets. So I know that 3 students went. Now I need to figure out how many adults went. So I'm going back up here. And actually, I'm using this equation here. I have A equals 8 minus, S is 3, so 8 minus 3. And so A equals 5. So there were 5 adults who went to the maybe, and there were 3 students. So if I had space, I would write that out in a complete sentence, but that does answer the question. 5 adult tickets and 3 student tickets were purchased.